Last time we began talking about slope a little bit. Today we'll go into quite a bit more detail about slope. So to review, draw a line that goes through points A at -8, 2 and B at 6, 8. So the first thing to remember is that to find one point, you actually need to look at two different numbers here. You'll be looking at the X and the Y. And just as in the alphabet, X always comes before Y. So your first number is going to be the X. It comes before the Y. So to find A, we need to look on the X-axis at -8. Here it is. To find our Y value, we need to look on the Y-axis at +2. And here it is. So now you have to figure out where those two meet. And here it is right now at point A. Now B can be found at 6, 8. So X-axis, find your 6. Y-axis, find your 8. And those meet right here. That's point B. The directions say draw a line that goes through the points. So make sure that you are connecting your 2 points, draw your line through them, and make sure that you put arrows on the end of your line. That shows that the lines go on forever. Good. Now we said that slope is the rate of change of a line, which is similar to steepness. We also talked about 4 types of slope: positive, negative, undefined, and 0 or no slope. Label each type of slope on the coordinate planes below. So please go ahead and pause the video here and write on the blank lines either positive, negative, undefined, or 0. Okay, let's look at the first coordinate plane. I see a line that is going what I think of as uphill. It is rising as I look left to right. This is going to have a positive slope. This next one is quite steep, but it's going downhill as you look left to right. This is a negative slope. My third line is not changing at all. As I move left to right, there's absolutely no change. And this line has 0 slope. My last one rises infinitely across the y-axis. It goes up 0, 1, 2, 3, 4, 5, all the way, infinitely. So it has an undefined slope. It rises infinitely, but it never changes across the x-axis. We call that undefined. Next page. Today we're going to learn how to calculate the slope of a line and come up with an exact number. The easiest way is to look at how quickly the line rises or falls or drops for every space the line goes to the right. And you'll see slope written in 2 ways that mean the same thing. The first way that you might see slope is like this: rise over run. And this black line here is a fraction bar, so you will see slope written as a fraction. The number for how much the line rises over the number for how much the line runs. The other way that you will see slope written is like this: change in y over change in x. These actually mean the same thing. When you talk about how much the line rises, you're talking about the vertical displacement, which would be the change in y. When you talk about how much the line runs, you're talking about the horizontal displacement, which would be the change in x. Well, let's get some examples so it's not so confusing. Here's a line that has already been graphed for you. This line goes through the points -2, -1, and 4, 3. Here's -2 and -1, and here's 4 and 3. Now the first step is to find a starting point. This is a little hint that I came up with after a couple of students weren't sure where to start even figuring out slope. Slide the index card to the right. Just cover your whole graph up. Slide the index card to the right, and the first point that you come across is going to be your starting point. And there it is. I will use that as my starting point. As you continue sliding the index card to the right, you'll be able to tell if the line is rising or falling. Let's do that. This line is rising, so the slope will be positive. If the line was falling, you would need to use a negative number for your slope. Next page. The second step to calculating slope, then, is to count the number of spaces that you need to go straight up, which is the rise, and then turn right, which is the run, to get to the second point. Now, I like to think about this as being in a big city, maybe Seattle or New York City. If this is your house and this is your restaurant, are you allowed to go in a straight line, cutting through everyone else's homes and businesses to get to your restaurant? No, you're not. You have to plan on a map how to go along the city blocks. In this case, you're going up 4 blocks and over 6 blocks. So make sure that when you're counting, you're going up or down and then over. So you start from your first point. What was the rise? In order to follow my map, I had to go up 1, here we are, 1, 2, 3, 4. I went 4 blocks. That's my rise. From this spot on my map, to get to my restaurant, I have to go over how many? Looks like 1, 2, 3, 4, 5, 6. I had to go over 6 blocks to get to my second point. And that is my run. So you went up 4 on the x-axis. I'm sorry, up 4 on the y-axis and over 6 across the x-axis. So you're going to put it in rise over run or change in y over change in x form. The slope then is, the rise was 4 and the run was 6, 4 over 6. And I put a note here for you. Always reduce slope to its simplest form and leave it as an improper fraction, if it is an improper fraction. So 4 over 6 can be reduced down to 2 over 3. Now let's try another one. Remember, your first step would be to find your starting point. Cover it up, slide your card left to right, and do you see a point? There it is. Right there is your first point. And here's another point here. Sometimes you'll have to choose from a variety of different points, but for this example, I've just given you 2, the first and the second point. And can you tell anything else about this line just by looking at it? Do you think the slope is going to be positive or negative? As I slide my index card over, the line is dropping. That's going to have a negative slope. Next page. So again, use an index card to help find your starting point on the left, and then decide if you need to rise or drop to get to the second point. Here we go. Starting point, and we're dropping. So we're going to have a negative slope this time. Let's not forget our negative number. To get from point A, maybe my house, to point B, maybe the restaurant in New York City, I have to follow straight lines. I'm not going to be going across everyone else's homes. So the change in y then, I went 1, 2, 3, 4, 5, 6 blocks I had to go before I could get to my next street. From here I had to go 1, 2, 3. So the rise over run would be 6 over 3. And make sure you put a negative there because you dropped down 6. Not done yet. I need to reduce this. Negative 6 over 3, that can be 2. My slope here is negative 2. Or it would be okay if you just wanted to put 2 over 1, but I think negative 2 looks a little bit better. Now practice finding the slope of the following lines. Go ahead and pause the video here and work on this one. Okay, step 1, find your starting point. And here it is. I'll use this as my first point. And I have another one here already shown. This is my second point. However, remember, you could choose any point along the line. I just gave you some easy ones. How do you calculate the slope? Well, it's rise over run, or change in the y-axis over change in the x-axis. So I got my points, and now you should be able to tell just by looking at this line, is it positive or negative? The line's going uphill, it's going to be positive. Let's use a highlighter and make our map here. We are going to rise like this, and then we're going to run. Count the blocks. We went 1, 2, 3, 4, 5, 6. We rose 6. How many did we run from here? 1, 2. 2. 6 over 2 can be reduced to 3. And again, this is a positive line, so it needs to have no negative. Next page. Now I'd like you to calculate the slope of this line. Please pause the video here and work on this top graph. Okay, find your starting point, and there it is. That'll be point A, or my first point, and I see a point here. We can use this one. Might help to use the highlighter again. All right, this time from this point, we're going down and over. Notice that I just said down, or we're dropping. So my slope this time is going to have a negative number. This is a negative slope. How many blocks do we have to drop? We started here, 1, 2, 3. Or you could count the entire blocks, right? There's 1, 2, 3. There were 3 blocks to drop, or change the y-axis. And how many blocks do we have to run or change an x-axis? From here, we had to go 1, 2. And you can leave your answer like that. The slope is negative 3 over 2. So our last coordinate plane here has a black line, looks to be right down the middle. Pause the video here and calculate the slope of this one. All right, find your starting point. I'll use this one here, point A, or my first point. And my next point here, my second point, will be B. So first of all, can you tell if this line is increasing or decreasing? It is increasing as you go, so the slope is going to be positive. You don't need a negative number. Get out my highlighter, plan my map to get from my home to my restaurant, only going along straight lines and turning at a right angle. Rise, looks like I can go over here, and run. Count your blocks. 1, 2, 3, 4, 5, 6. 6. And 1, 2, 3, 4, 5, 6. And 6. So the slope of this line is 6 over 6, which is 1. Now I'd like to do something a little bit interesting here on the same graph. What would happen if we used a ruler to show our line and we increased or decreased the steepness? If I increase the steepness of my line, let's say something really steep, maybe here. Let's use a different color, maybe red. Let's put a dot maybe here. And how about maybe down here, make it really steep. Now let's figure out what the slope of this line is. How much did I rise? 1, 2, 3, 4, 5, 6, 7, 8. For this one, I rose 8. And how many did I run? 1, 2, just 2. So then the slope of this line would be 4. So I started with a slope of 1, I increased my steepness, and now here I am at a slope of 4. I could actually keep on going and get a slope of 5, 6, 7, 8, 10, 20, 100. If you have enough detail, you can get even higher than that. On this graph, I think we can stop there. Using a different color, let's decrease the steepness of my line now. Maybe something like this. Let's grab a purple color. How about here? And then maybe something like this. So I'm decreasing the steepness of this line. And you can make a guess about what's going to happen to my number for slope. Do you think it's going to be greater than 1 or less than 1? Hopefully you said it's going to be less than 1. If this line has a slope of 1, this has a slope of 4, as I decrease the steepness here, it should have a slope of less than 1. Less than 1. Well, let's see if we're right. All right, starting here, your rise, 1, 2, 3, 4, 5, it had to rise. And the run here, to get all the way over to this spot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5 over 11 is your run here. And that's going to be a little bit less than 1/2. Let's just call this 1/2 to make it easy. So my original line here had a slope of 1. As I increase the steepness, my number for my slope gets higher and higher. As I decrease the steepness, the number for my slope gets lower and lower. It will be 1/2, 1/4, 1/8, 1/16, all the way down to a horizontal line, which has a slope of 0. And as I kept tipping it this way, my numbers would be negative. Okay, that was a little bit complicated, but hopefully you got the basic idea there. Great job.